Hello everyone, I'm Joe from Huawei Smart PV Marketing Department. Now I will continue to lead you through our solution in utility PV plants. With the rapid development of emerging ICT technology, such as the AI, cloud, big data, and 5G, and also in full consideration of the latest trend in power electronics, Huawei has engaged with experts in the field and released the 9 emerging technical trends for smart PV in 2025. The trends aim to drive the industry toward intelligent and green solutions and provide insight into the innovation and soaring growth in the PV industry. Huawei expects the future of smart PV shall be developed in 3 major directions. The first is digitalization. In the future, data will become the most fundamental resource for the digital world, and all data in the PV plant, from modules, tracker, inverters, and etc., shall be sensed. So we expect that by 2025, only 90% of the PV plant will be digitalized. And the mass data will be processed with AI to help improve the system operation efficiency, which is previously performed with expert experience. We expect AI to be deployed in system design optimization, fault detection, solar storage collaboration, and more aspects to make the system smarter. With these 2 digital foundations in the future, we believe the unmanned operation and maintenance in the PV plant will be the mainstream. The drones will be deployed for the plant inspection, and the assistant robots can help repair and replace devices with remote control. We expect that by 2025, 90% of the PV plant will be unmanned and at least with light manual operation. The second is grid supporting. Currently, the installation capacity of renewable energy accounts for 10% of the total power plants, while the energy generation accounts for only 2% at this moment. In the future, as the renewable energy become the main energy source, its effect on the power grid will be enlarged year by year. Therefore, we expect PV plants shall transform from following the grid to actively supporting the grid. When the grid failure occurs, the PV plant shall not trip, and the output power shall be stable with the low harmonics in order to maintain the voltage and the frequency of the grid. The PV plus storage is expected to be a new trend for grid supporting. In 2025, we expect 30% of the new PV plants will have storage. However, the smart collaboration between the solar and the storage to improve the system efficiency will be another new project for the PV solution suppliers. And also, in distributed PV scenario, the virtual power plant is expected to become a most efficient way for small rooftop plant owners to attend the energy market, and at the same time, for grid operator to acquire support from the decentralized storage system at a reasonable cost. The third is system and component upgrade. With the development of the material and heat dissipation and algorithm, we expect the components in PV solution will be upgraded in 3 ways. First is the modular design. Since 2013, Huawei has been focusing on string inverter and witnessed its advantage in higher use, simple maintenance, and improved availability. This is the reason why we decided to stick to modular design for all devices in the future, like the solar inverter, the PCS, the battery, and etc., to reconstruct the system architecture and boost system efficiency. The second is the higher power density. The modular design is based on the development of material science, the heat dissipation technology, and the manufacturing techniques. In the future, as new materials like the silicon carbide and the gallium nitride will be widely deployed in inverters, the large power capacity devices will be of acceptable dimension and weight, and perform as a modular component. And we believe in the future, the devices, systems, and the networks shall be trustworthy. The reliability, availability, security, safety, and resilience and privacy will become essential requirements in the future. So, based on the understanding above, Huawei provides FusionSolar 6.0 Plus, the utility smart PV solution. Consists of the 185 smart string inverter, smart area controller for the data transmission and control, the smart transformer station for overseas ITS solution, and smart PV management system for real-time monitoring and management. And today, I would like to introduce our latest progress, how we deploy AI technology in FusionSolar. The smart tracker control algorithm and the smart IV curve diagnosis in 4th generation. And the last one, the smart grid connection algorithm. So Huawei will use AI boost FusionSolar smart PV solution targets to reduce LCOE and the support grid. I will interrupt the 3 key new features individually in the following pages. The first one, we know that tracker can significantly increase energy generation, and as the price goes down, more and more plants deploy tracker to reduce LCOE. Currently, the trackers employ the astronomical algorithm to ensure the modules to be perpendicular to the direct sunlight. However, the uneven landscapes in the PV plant is not considered. The row difference can cause the internal row shading in the backtracking in the morning and the evening. And also, in cloudy days, the diffuse light accounts for a higher ratio than that in normal days. And the tracking angle without optimization cannot harvest as much power when the light is scattered. Huawei integrates AI and collaborates energy generation with tracking algorithm to optimize the tracking angle through the recurrent neural network. Based on the mass data from the plant performance, Huawei optimizes the algorithm to best match the plant. And during the backtracking, Huawei adapts each row to avoid inter-row shade and capture more solar energy. And when cloud rows occurs, smart control algorithm can sense the irradiation change and reposition tracker to harvest more energy. And what we introduced here is only achieved by the algorithm upgrade, without any cost of additional devices. And we have tested technology in PV plants in different latitudes all over the nation. And the results show that compared with the standard mode, the smart control algorithm can improve the energy generation by over 0.5%. This technology utilizes standard interface and communication protocol, and it's quite easy to collaborate with different vendors of trackers. So we highly welcome our partner worldwide to experience this simple and high-efficiency AI improvement. And we also use AI to reduce OPEX as well with smart IV curve diagnosis. This idea was a collaboration between us and our key strategic customer. We smartly combined the abundant O&M knowledge with the information and the communication technology and developed an online inspection and the diagnosis of all PV strings in a quick way. Compared with a conventional solution that uses the on-site sampling test and the time-consuming manual analysis, the smart IV curve diagnosis can largely shorten the time from weeks to half a day. AI learns expert knowledge and can accurately identify 14 types of string failure, which is certified by TÜV. This diagnosis can further provide troubleshooting solution to close-loop the O&M process. This function has been deployed in 5 GW PV plants worldwide now, and Huawei continues upgrading the algorithm to suit more and more scenarios. In this year, the 4th generation can support diagnosis of the mono, bifacial, shingled PV modules. It is also compatible with the mixed installation of different PV modules in one string and the Y-branch connectors. We provide license for this function, and any customer with Huawei Smart PV solution, either for the existing or the new PV plants, are welcome to try this function. As the LCOE of PV continuously decreases, solar is expected to become the major energy source. According to the International Energy Agency's outlook, in the near future, over 30% of the annual newly installed power plant will be the PV plant. However, with the increasing renewable energy construction scale, the SCR of the power grid is gradually reduced. The short circuit ratio is a typical indicator to measure the strength of the power grid. It can be used to measure the impact from the power injection from the PV plant to the local power grid. With increasing renewable energy and the traditional generators like thermal power plants in some countries are withdrawing, we can find the SCR of some regional power grid will be lower and lower. Or in another way, more and more regions will face a new challenge of weak grid. The chart on the right is based on the Bloomberg's prediction of renewable energy penetration in several regions. It is expected that between 2025 and 2030, the SCR will be lower than 2 in some countries here. Huawei has been researching on the grid connection PV technology for many years and improving the control accuracy. Currently, Huawei has achieved a stable grid connection in all PV scenarios. The value of this technology for customers is that the site selection under the conditions of the changing power grid is not affected. The algorithm supports a stable grid connection in weak power grid with SCR down to 1.5, and improved higher fault read-through capabilities. At the same time, improves power quality by suppressing the current harmonics less than 1%. And here are some testing curves. In the weak grid connection testing, the output waveform of Huawei inverters is still stable when SCR is 1.5. However, the output waveform of other string inverters are distorted when SCR is 3. The inverters can work only with reduced power or switch to shutdown for self-protection. In terms of the power quality, in a real power grid with the background harmonics, when THDU is about 4%, Huawei inverters ensure the THDI is less than 1%. In comparison, other string inverters can barely achieve the claimed THDI of less than 3% in laboratory conditions. In a real power grid, the harmonics would surge to 9%. Besides the testing result, we know that Australia's new standard in February 2019 is the world's most stringent power grid standard. Huawei helped our customers to get first admission to this new grid standard for 35 MW PV plant in Victoria. The pro time for this project is only half of other solutions. And in China, Huawei SUN 2000 inverter is the first to meet the new technical requirements for grid-connected inverter, which calls high requirements on high voltage read-through, low voltage read-through, and frequency adaptation. And another real case occurred in northeastern China in April this year. A grid fault of face-to-face short circuit occurred and led to the low voltage in this local grid. From the recording diagram, we can see that the central inverter in a 100 MW plant failed to low voltage read-through and shut down for protection. While at the same time, another 20 MW PV plant utilizing the Huawei inverters accurately identified grid faults and ensures stable operation after successful low voltage read-through. What's behind this case is the SCR is getting lower after this 20 MW was grid connected. Okay. When only 100 MW PV plant was grid connected, the SCR was about over 2. With another 20 MW getting connected, the SCR has decreased to 1.85 only, which is typically weak. So what we learn from this case? For long-term PV plant operation in daily change grid scenario, a smart inverter with strong grid connection algorithm become particularly important. Okay, that's all for my presentation today, and thank you all here for your attention. We hope everything goes well, and we are looking forward to see you again face-to-face very soon. Thank you very much.